RC equal to P plus Q plus MC. This becomes L. Okay, and then for this one we take the
So why is RA again going in like a horizontal direction? Like why isn't it going vertically?
Because here we only have the horizontal the loading in the horizontal directions. You might assume additional RA. How about this? We call it RAY. But for this case, you can see the RAY will be is not necessary. Probably we can assume the RA, this one will be equal to 0.
Because there's no.
Because here, original, we only have the loading in the x direction. That is assumed.
Yeah, okay.
Okay. So now for this one, we can calculate P plus Q plus I equal to 0. So I. Okay, with those things in mind, and we have to set up both the loading equal to 0. So now we take up this template. So for this case, we partial U, partial Q, then basically that is the, and so partial U and partial Q would be, for example, 0 M EI partial M partial Q dx. Okay, and then we can do the same thing for partial derivative with respect to NC. So that is a tabulation as we go forward at here. The vertical, and then we have the member BC. Let me finish this one here. Okay, so by all means, what we need are, let me circle the information we need. We need the bending moment of M of x in each portions. And we need is the partial derivative of the moment about our individual virtual load. Okay, so we need those informations, and so we get ready for each portion here. So for the member, the bending moment, here this is our corner systems. So here is x and vertical is y. So right now we're focusing is in this portion. And so why not I take this is the displacement y. Sorry, the variable y for denoting the describing the bending. So for the portion AB, can I draw this here? So if I would take this free body diagram, the distance is y, okay, and now this is our RA here. So therefore, from here you can see the RA multiplied with I must be in balance with the bending moment. Okay, the bending moment is at the position y. So for this case, that is the RA times y. This number is what we're looking for here. Okay, remember the diffraction, the bending moment in terms of the distance y will be equal to RA times y. And RA equals to that value here. And again, I drop the negative term to focus on only magnitude of everything here we calculated. Okay. And also we need is the partial derivative with respect to each term. So for this case, the partial n and partial q will be equal to 1, and then partial m and partial nc will be equal to 0. Okay, and then for this one, for the portion BC, for portion BC, I think this way you can really arbitrarily define your corner systems, but I think more convenient way is I take the free body diagram, I take the cut here, I consider this portion as my free body diagram. I will consider that distance measuring from the tip, from this end to there, that is x, okay? So for the portion B, that is our free body diagram here. So this is x, and then our reactions, our loading case, this is RC, and this is Q, this is MC. So now for this case, we have the bending.
Would just be MC plus some RC.
Yeah, so bending, that is a function of x. So from here, we can quickly write it down. The bending in this portion of, in terms of x, will be equal to MC plus RC times x. Yes. And that one equal to MC plus RC equal to P plus Q plus MC over L times X. Okay. And then here we do the calculation. Partial Q will be equal to X, and partial M, partial MC will be equal to 1
Plus X over L. Shouldn't it just be plus X over L?
I have a typo here.
Where?
I'm looking for.
You should, yeah, because RC should be P plus Q minus MC over L.
Yes, this here. Okay, so we got everything done here, right? So now we can calculate. So therefore, the diffraction at point C will be equal to partial U and partial Q, and we set up Q equal to 0, MC equal to 0. The U will be from the partial U, partial Q, if we take out this portion here. So that portion will be Q portions, and in this is in AB, and that one is we look at this one carefully. And EI and partial M partial Q EX plus in BC and M EI partial M partial Q EX. And remember setting the whole things Q equal to 0, MC equal to 0. Then we simply plug in those information in portion AB. That is information here, and that is a function of y. You keep that in mind. So that means here, when you do the integral, that is an integrate over y,
It's not.
right?
Dx is stupid.
Yeah, so basically try to refine the whole calculation, not to confuse yourself. And then for here, the remember BC is in terms of x, and remember that is our x, and our integration is from right to left. Okay, so keep those things in mind. And so right now we have everything here, and my, this term is ready here. Partial m, partial q, that is here ready. And simply we plug in those things carefully, and that one will give you certain something of PLQ of EI. And the denominator is 3. Okay, so you try to do a little bit more rigorous and then try to implement this one. This is an integer. And you did see? Partial U and partial MC and Q equal to 0, MC equal to 0. The same thing here. Okay, so simply we have AB and partial M function of y and partial M partial MC. This one we have this one here, so this one equal to 0.
Do you take the partial of that my in the first term? Yeah. Left.
This one?
Down. Left. Do you take that partial?
0?
No, left. I know it doesn't matter, but...
Oh, sorry.
Sorry, okay, yeah,
Yeah.
sorry. I just confused
No,
myself.
partial, yes. So this one is really here. Okay, so again, this one we calculate Q equal to 0, MC equal to 0. So this number will be certain something, and again 6 over something, and then P, L, Q, and EI.
So like something like this on the test, because the biggest issue is trying to realize if you don't have bending or if you do have bending, because that was like my issue,
Yes.
I guess.
Yeah, so the issue is as long as you write up certain justifications, then convince me. If everything is so reasonable, so logic, then I will follow up.
What if we don't convince you?
Most of the time, you convince me. Okay, most of the time you convince me. And so that's for the homework. And again, this is an integer number. Okay, both are integer numbers and positive. And one more thing. For this one, which direction? I think that is the counterclockwise. To tell the directions from the beginning, you might be just assign the sign convention for m. So by using the sign convention for m, positive counterclockwise, then eventually you will get the sense of the direction. And I don't want to confuse you, but from the beginning when you read you try to get a sign from here. And that is the starting point. If you want to get a sense of the direction starting from here, get everything follow sign convention. Our sign convention is positive counterclockwise. Once you have a sign here, keep everything persistent, and to the final end, whatever, if this result is positive, counterclockwise. If this result negative, clockwise.
So, but
Okay. And I have a few more. I think 1 or 2 more examples, and if necessary, Wednesday we can go over those examples if necessary.
Yes.
Okay.
Yeah.
And then I think in this way the homework is not so rushed. I will make an official announcement. The test will be on Monday next week, and the homework I'm going to collect on Thursday. Hopefully, give you enough time to maybe read you and to rehearsal the whole thing. Thursday.